We start with facing using constant cutting speed, G96. The cutting speed is set to 200 meters per minute. The tool approaches at Z0.1 and moves across the face to a machine it flat. The cut ends at X24, leaving a small rest, a circle with a diameter of 24 millimeters. Here's why. With constant cutting speed, the spindle's speed would have to keep increasing as we move closer to the center, theoretically up to infinity at X0. In practice, however, the spindle cannot accelerate indefinitely due to the RPM limit. As a result, the actual cutting speed drops sharply near the center, almost to zero. At that point, the tool would no longer cut effectively but only push material aside. And since this spot will be drilled afterward anyway, the path to the axis is skipped, saving tool life. Next comes the drilling cycle G84. For this, the mode switches to constant spindle speed with G97, since smooth running is more important than constant cutting speed during drilling. The core hole is drilled down to Z71, forming the basis for the internal machining. Now it's time for the contour. With G81 longitudinal roughing cycle, the roughing parameters are set, depth of cut and stock allowance. The stock allowance ensures that enough material remains for finishing to achieve a clean surface finish. The actual contour is stored in a subprogram and called with the G22 command. All geometry elements are defined there: straight lines, chamfers, radii, and even an arc. The advantage: once programmed, the contour can be reused multiple times. This benefit becomes clear during finishing. With reduced feed, the same contour is machined again, this time for accuracy and a smooth surface finish. After that, it's time for the internal thread, a classic exam task. The threading cycle G31 performs the operation in multiple passes. The key point here is that in X we don't enter the nominal diameter, but the core hole diameter, which is calculated as the nominal size minus 2 times thread depth. Pitch and thread depth are specified in the reference tables. The control automatically distributes the cuts across several passes until the thread is complete. Finally, radial and axial grooving is carried out. The grooving cycles G86, radial, and G88, axial, use the address LE to define the groove position. In this program, that means radial grooving is done with LE2, which is from the inside across the axis. LE1 would be from the outside. For axial grooving, LE1 defines machining from the face toward the axis, while LE2 indicates grooving from the backside. With that, the workpiece is finished. You'll find more instant CNC on our channel for both turning and milling.